Okay, class, this is a video where I'm going to introduce you to polynomial functions. It's basically an introduction to polynomial functions. During this video, please feel free to pause it and then copy these notes on a piece of paper so you can refer to them later. So, chapter 3 on your Math 3 book talks about polynomial functions. The first section is on how to define polynomial functions and graph them. A polynomial function is a monomial. A polynomial is a monomial or the sum of monomials. A monomial is like an expression like a 3x or 5 or negative 5x to the second power or something like that. So it's a monomial. When you add them up or subtract them, you get more than one monomial together, you get a polynomial. So polynomial function has the form a right here. It has this form right here. And it might look a little complicated, but it's not as confusing as it seems. So the polynomial function has this form here. It's confusing: a sub n times x to the n plus a sub n minus 1 times x to the n minus 1. So that form looks confusing, but if you look down here in an example, we have negative 3x to the 4 plus 6x cubed minus 5x to the second plus 11x minus 8. This is an example of a polynomial. So in a polynomial, all the exponents, this is one of the conditions or the definitions, or part of the definition of a polynomial function. All the exponents are whole numbers. So that means there's no decimals, there's no negatives, there's no fractions, and there's no irrational numbers like pi or the square root of 2, for example. All the exponents are numbers like 0, 1, 2, 3, 4, 5. So whole numbers are going to be numbers like 0, 1, 2, 3, again. So all the exponents are whole numbers. That's the definition of polynomial function. So in a polynomial function, a sub n is the first number or the number next to the x with the highest exponent. It's called the leading coefficient. N is the highest exponent, is the biggest exponent of all of them. It's called the degree of the polynomial. And a sub 0, the number at the end that has no x's next to it, we call it the constant term. And so in our example down here, so please write this down, pause the video and write this down on a piece of paper. In our example right here, a sub n is the number in front of the x with the highest exponent is negative 3. N is the biggest exponent is 4. And a sub 0, the constant term is negative 8, the number with no x's. So a sub n is called the leading coefficient, so it's negative 3. The degree is 4 because it's the biggest exponent, and the constant term is negative 8. So this is the kind of vocabulary words that we're going to be dealing with the whole chapter. So make sure you are familiar with them. Please pause the video and copy this down. The definition of a polynomial function, here's the definition. A polynomial function is in standard form if the exponents are in decreasing order. Decreasing order. Okay, so for example, if you look at this polynomial function right here, f of x equals negative 7x to the third plus 6x squared minus 12x plus 5 is in standard form, or is in standard form because the exponents go from 3 to 1 and then no exponent at all. So we call that standard form. This is not in standard form. So this function is not in standard form. If you wanted to write it in standard form, what you have to do is rearrange the exponents in decreasing order like this. Well, I guess that was a bad example. Let's make that 2x to the second. Let's say it had been 2x to the second, so that we could write this in decreasing order. So now this is in standard form. So really simple, just put all the exponents in decreasing order from biggest to 0 or to the constant term. We have some other vocabulary words. So what do we call a polynomial function? We have names for polynomial functions based on the degree. If the degree of a polynomial function is 1, if it's 0, we call it constant. And an example of a polynomial function in standard form would just be f of x equal to a to the 0. As an example, it would be f of x equal to any constant, for example, negative 5. So the degree here is 0, because here we could add an x to the 0, negative 5x to the 0 power if you want to. So the degree is 0. Anyway, the degree is 1. If the degree is 1, we call it linear. Some of these words you are familiar with. So the degree or the exponent, the highest exponent is a 1. An example of it could be something like negative 2x plus 7. This is a linear function. When you graph this, you get a line. If the degree is 2, we call it quadratic. And here's an example. I'm sorry, I'm going up, I guess. So if the degree is 2, we call it quadratic, and something like 5x to the second minus 9x plus 2 would be an example of a quadratic function. If the degree is 3, we call it cubic. So here's a standard form, and then an example would be something like negative 8x to the third plus 2x minus 1, for example. As long as the highest exponent is a 3, we call it cubic. If the degree is 4, we call it quartic. And here's the example in standard form, or the general form. And then as long as we have a degree of 4, so something like negative x to the fourth plus 7x squared minus 9, that could be an example of a polynomial function with a 4th degree, and we call it quartic. After the 4th degree, we just call it 5th degree polynomial, 6th degree polynomial, 7th degree polynomial, and so on and so on. So we only have 5 names for constant, linear, quadratic, cubic, and quartic. Please memorize that. Here's an example, a typical example in this section of the book of or this type of problems here. It says determine if the function is a polynomial function. So we're going to use the definition. If it is, write it in standard form and find the degree, the type, the leading coefficient, and the constant term. Please remember that the coefficients could be any real number, but the exponents, they have to be whole numbers. 3 is a whole number, but 1/2 is not. So we say this, you could say, since 1/2 and the square root of 2, that's the next exponent, are not whole numbers. And therefore, f of x is not a polynomial function. It is a function. It's a different type of a function, but it's not polynomial. If you look at all the exponents on the next example, in part B, we have an exponent of 1, 2, no exponent, that's a 0, and then there's a 3. All of those are whole numbers, so then f of x is a polynomial function. I'll just put fn for function. And then, so how do we write in standard form? I'll just call it SF. Standard form would be, just rearrange the exponents in decreasing order. So it's 2x to the third plus 8x squared minus x minus 10. We have to find the degree. What is the degree of this polynomial function? The degree is 3, is the highest exponent. The leading coefficient is the number in front of that. So it's 2. And the constant term would be negative 10, the term with no x's. You're welcome to stop the video before I even write the answers to see if you understand it in the next example. So find whether it's a polynomial function or not, then write it in standard form. Then find the degree, leading coefficient, and constant term. So it is a polynomial function because 3, 1, and 2 are whole numbers. And so it is, in standard form, it would be negative 5x to the third minus 4x squared plus 2x. Notice that the constant term here is not there, but we could assume it's a 0. We could always add a 0 here. So that will be the constant term. You don't have to write it down, but just know that it's there, and it could be kind of a 0. The degree of this polynomial function is 3. The leading coefficient is negative 5, and the constant term again is 0. And by the way, I forgot to mention the type on the previous one. So what is the type? Because the degree is 3, we call it cubic. On this one, the degree is 3 as well, so we also call it cubic. Please refer back to the chart up here where for the names or the types of the polynomial functions. Okay, evaluating functions, and this is the last part of this video. Once we know what a function is and how to classify them and how to name parts of it, we also need to know how to evaluate functions at some values of x. So evaluating this function when x equals negative 2, all you have to do is substitute every x by a negative 2. If you do find a mistake in this video, please let me know. Negative 2 to the third power is negative 8. 2 times negative 2 is negative 4. Negative 5 times negative 2 is positive 10. And another 10, this is going to give us positive 8 minus 4 plus 20. So I believe the answer is 24. So we say f of negative 2 is 24. We follow the order of operations to do this. When x equals 1, you just write a 1 for every x. Keep in mind the order of operations again. Negative 1 times negative 1, 1 times 1 times 1 is 1, but there's a negative 1 in front of it. So this is 1 minus 4, it's minus 5 is negative 4, plus 10, I believe the answer is 6. So f1 is 6. When x equals 1, y equals 6. That's what this says. And finally, if you let every x equal to 0, all of these terms are going to turn into 0. Because a number 0 to any power is 0, 0, and then 0 times any number is 0. So this is really 0, 0, and negative 9. So the answer is f of 0 is negative 9. So this is how you define polynomial functions, how to identify them, name parts of it, and then how you evaluate. Please watch this video and copy it on your notes, copy these examples on your notes, and use them to complete your assignments. I'll go ahead and record the second part to this video and post it on your Google class. Thank you.